Hello, my name is Bojan Mitov, the president of Mitov Software, and in this session we will demonstrate creating beautiful animations in your Delphi desktop and mobile applications. Animation Lab allows you to easily create beautiful timeline-based animations with no code and very little effort. It can animate any property through OpenWire Visual Live Bindings. It can be used to animate visual and non-visual components. It contains a timeline component and a simple physics engine. It can animate both VCL and FireMonkey components, as well as non-visual components such as database access components, as example. Currently, it works on Windows, Mac, and Android. The timeline component can contain one or more animation channels. Each channel can be of different data type: real, integer, color, alpha color, string, boolean, date, time, and even event. Timeline channels can start and stop other timelines. The timeline channels themselves can contain multiple time periods. Each period can last different time interval. Each period can be of different type: linear, spline, sudden value change, etc. Each channel can control one or more properties. There are also channels that can generate events at specific time. To demonstrate this, I have created two Delphi projects. We'll start with the FireMonkey project. In this project, we have a viewport 3D where we'll have three-dimensional scene. We have a three-dimensional model. The model has round cube, sphere, and text. And we have one sphere in the viewport which is not part of the model. We also have added some lighting, and we have few material sources used for the different elements in the scene. Now we'll add a timeline. We'll double click on the timeline, and this will open the timeline editor. For this demonstration, we're gonna dock it. We'll add two real channels, one alpha color channel. For the real channel 1, we'll add two linear periods. We'll set initial value for the channel to -10. Value for the first channel of 10. And ending value for the second channel to -10. Next, we'll select the model and we'll add Visual Live Binding for it. We'll select the X position and we will set floating sync pin. We'll switch to the OpenWire editor and we'll connect the first channel with the X position. And we also will set the timeline to loop. And we'll run the application. We can see that the model is moving left and right. Next, we'll expand the two intervals to have 10 seconds interval. For channel 2, we'll add a cubic spline. We will set the interval to 20 seconds. Then we'll add 5 points to the spline. We'll put some interval and values for each point. Next, we'll add some more visual live bindings for our model. We will add the Y position sync pin, and we will connect the second channel with the Y position. Let's run the application. And you see that now our model is animated both on the X and Y axis. Next, we'll select the alpha channel. We'll add 2 linear periods, one cubic spline, and 3 value periods. We'll select the channel and we'll set initial color of red. For the first period, we'll select ending color of blue. For the third period, we'll set ending color of yellow. For the cubic spline, we'll add 2 points. We'll set the interval for the first one to 0.8 and we'll pick some color for it. Then we'll select the second one and we'll set some other color. We will also resize a little bit the linear channels, so the animation will be more interesting. For the first value, we'll select ending color of blue. we'll add one more value, and for the second one we'll set a color of red. For the next value we'll set color of yellow. We'll add another value and we'll set some other color. This should give us plenty of fun colors. We can also resize some of those intervals to make it more interesting. We'll select Light Material Source 2 and we'll add Visual Light bindings to it. For its ambient color. We'll switch to the OpenWire editor and we'll connect the animation channel to the material source. Let's run the animation again. Now you can see that the color of the round cube is changing as specified by the channel. To make it more interesting, we'll add another timeline. In this one we'll add only one real channel and we'll add 2 linear periods in it. We'll set initial value for the channel to -10, value of the first channel to 10, and of the second channel to -10. Next, we'll select again the model and we'll add new Visual Light binding for it. In this case, we'll add rotation angle over the y-axis. And in the OpenWire editor, we'll connect timeline 2, channel 0 to the Y rotation angle. We'll set the timeline to loop and we'll run the application. You can see that now as the model moves, it rotates left and right. Now we'll add a third timeline. In this timeline, we'll add one real channel, one alpha color channel, one Boolean channel, and one string channel. We'll use this timeline to animate the text. In the real channel, we'll add one cubic spline. We will add some points to it. And some values for their intervals and positions. For the alpha channel, we'll just add 2 linear periods. We'll set initial value of blue, value for the first period red, and will not change the third period. For the Boolean channel, we'll set only one value. We'll set its value to true, and we'll make the interval very small, so it is set almost immediately. For the string, we'll set 3 value periods. We will make all of them relatively short. We'll set the channel value to be high, the first period ending value of don't, third period do, and for the last period that. We will select the sphere, add new visual live binding for it, the Y position, we'll select the light material 3, add visual live binding for its ambient color, we'll select the text, add visual live bindings for it, for its visible Boolean sync pin, and for its text sync pin, and we'll connect all that in the OpenWire editor. We'll disable the timeline, select the round cube, and add on-click event on it. We'll select the timeline, and again with visual live bindings, we'll add binding for the start function. In the OpenWire editor, we'll connect the two, and we'll run the animation. If I click on the round cube now, we execute the newly created animation for the head and the text. Now it's time to animate our last object. We'll add another timeline, In it we'll add only one real channel with 2 linear intervals. We'll set channel initial value to 10, first interval to 8, and last interval to 10 again. We'll make each period interval to be shorter. We'll select the sphere and we'll add 2 visual live bindings for it. One for its Y position, and one for its on-click event. We'll select timeline 4 and we'll add new visual live binding for its start command. We'll set it to disabled, switch to the editor and connect the channel to the Y position and the start to the on-click event. Next, we'll select timeline 1 and we'll add event channel. We'll add 3 events and we'll put them each to happen at different time. In the OpenWire editor, we'll connect the start of timeline 4 to the newly added channel of timeline 1. This way, timeline 1 will also be able to start timeline 4. Let's run the application. If I click on this ball, animation will be performed, and also every now and then the main timeline will start animation for it. You can see that we can start the animation timeline both ways. We already mentioned that Animation Lab also includes a simple physics engine which has some effects. The effects are drag and mass effects, and they can be applied to a property controlled by a timeline. We'll demonstrate this with our project. We'll add a mass to the small sphere we just animated. We'll drop a mass component, switch to the OpenWire editor, and we'll connect it between the animation channel and the property it animates. Let's run the application. And you can see that now the animation has mass and wobbles. This is how you can add additional effects to your animations. We already mentioned that Animation Lab can animate FireMonkey, VCL, as well as non-visual components such as client datasets. To demonstrate that, I have created a very simple database project. I will also hook the list box into the database using Visual Live Binding. I will add new Visual Live bindings for the categories Then I'll add new Visual Live binding for the list box. And I will connect the two. If I run the application, you can see the list box is properly populated with the data. Now let's add timeline. We'll add two event channels and one integer channel. For the first event channel, we'll add 4 events. One event for the second one. We'll make its interval longer. For the linear, we'll add one linear period, one cubic spline period, 2 value periods, and again one linear period. We'll set the value to 27 for the first linear period. For the cubic spline, we'll add 2 points. We'll set value of 3 for the first one and value of 7 for the second one. For the end of the first value period, we set 8. And for the end of the second one, 25. Then we'll rearrange a little bit the time to make it more interesting. We'll select our client dataset and we'll add Visual Live bindings for it. Next, and prior. We will select the list box and we will add new live binding for it. We'll switch to the OpenWire editor and we'll connect the first channel to next, second channel to prior, and the third channel to the item index of the list box. We will set the timeline to loop, run the application, and you can see that both the client dataset and the VCL control are animated. And the client's dataset next and prior functions are called exactly as events. So I can navigate to the database and still the events will be fired and move to previous or next record. This demonstrates that we can both control VCL and FireMonkey components. We can animate almost anything. We can control timelines with timelines. We can apply effects. And we can do very complex animations in very little time. This concludes our session. My name again is Bojan Mitov, the president of Mitov Software. You can see on the screen our website as well as my email. Mitov Software is specialized in very fast video, audio, digital signal processing, computer vision, artificial intelligence, parallel processing, industrial control, and data acquisition. We offer a number of products. They include VideoLab, video processing library, AudioLab, audio processing library, SignalLab, digital signal processing library, VisionLab, computer vision library, PlotLab, data visualization library, InstrumentLab, visual instrumentation library, Intelligence Lab, artificial intelligence library, Logic Lab, Boolean logic library, Animation Lab, Universal Animation Library, Visual Live Binding, Universal Visual Live Binding Library, OpenWire Studio, a graphical development environment for non-software developers. We also provide the free Mitov Runtime Library for Delphi. In addition, we support a number of open source libraries, including OpenWire and iGDI+. A number of our products are already ported to support OS X and Android. We are working to expand that support across all the libraries and to cover the full range of platforms supported by Delphi. A number of the libraries also are expanded to utilize OpenCL for very fast GPU processing. Thank you for listening, and now it's time for questions and answers.
So Keith asks, he says, great components, Bojan. In the FireMonkey edition, can any descendants of T-shape, such as Ray, can work with other descendants of T-shape, such as Ray's new Radiant components?
Well, since the library uses live binding to bind to practically any property, you can animate absolutely any component, no matter whether or not it comes with Embarcadero or from any third-party vendor.
Well, that's good to hear, because he had some great components, Ray's did.
I saw them, and they look great.
Yeah, they do. What about, can you tell us more about your Mitov runtime library?
What is the question about it?
So just tell us more about your Mitov runtime library.
Sure, absolutely. I wanted actually to do some sessions about it, but we obviously all of the slots were full. It's a very interesting library which we offer for free, and it contains a large amount of features in it. It contains threading, quite advanced and new threading concept, altogether brand new threading concept. It also includes OpenCL support. It includes a more advanced RTTI than the one that comes with RAD Studio. The library, by the way, is not yet published on our website. It is still in development and should be published in the next couple of weeks. But anybody who is interested in it can contact me, and I have been providing copies of it. The library also has JSON serialization. It has a lot of features. It has very easy to use and quite powerful containers, and it includes a simplified design time component development framework, so you can develop components faster and easier for Delphi. So it has a lot of stuff, and yeah, we are offering the library completely for free. And all of our components now are developed with these libraries. So you can see the power of the library that runs under the hood.
Is your Signal Lab able to be used on Android and iOS?
The Signal Lab is not yet ported. Currently, the libraries that are ported are Logic Lab, Animation Lab, Intelligence Lab, the OpenWire, and the Visual Live bindings. We are working to get Signal Lab very soon ported. It is partially ported already. We are also nearing the completion of Basic Audio and Audio Lab. And Plot Lab is 90-something% ported. So Plot Lab is just around the corner as well. So those are the first to be ported. Then they will be followed by Video Lab and Instrument Lab. So yeah, we should have in the next few months all of the libraries ported to Android specifically.
Is there some video capture possibilities now, harvesting the activity together with speech to make videos from lessons, etc., like those made to prepare this lesson?
That's an interesting question. We don't have dedicated text-to-speech component. It's possible with our components. It's possible to get with third-party text-to-speech engine to get the audio data and pass it to the components for recording. Video Lab can do that, but it requires a little bit of coding to get the text-to-speech engine integrated. I believe you had a session on text-to-speech.
Yes.
So maybe we can work together and make such a demo.
There you go.
That would be an interesting option.
Does the Animation Lab work with XE7?
Absolutely. Yeah, we don't have official XE7 release yet. I posted a couple of weeks ago a pre-release version on my blog. But anybody who contacts me, I have been sending the latest pre-releases. The pre-releases are very stable. They are production quality. The only thing that's not quite there yet, as usual, is the documentation. So we are working around the clock. Yeah, you can see actually the post right here. And the documentation should be ready any time now, as usual. Yeah, documentation always lags behind. I'm sorry about that.
What was the licensing price on Animation Lab?
I have to look at it should be in the pricing table. So if you select the pricing table, it should be there. I don't recall it off the top of my head, but let me check it. Yeah, we have so many products, I can never remember all of the prices.
Yeah.
Animation Lab is $129 without source code and $429 with source code.
Okay. Excellent. Well, if you guys have any more questions for Boyan about Animation Lab or any of these other products, Mitov software, go ahead. Oh, wait, here's one here. What are the different effects in the physics engine?
Right at the moment, there is mass and drag effect only. And yeah, I'm very open to suggestions for other effects. I simply have not been able to come up with other ones at this point. The drag effect is like fluid type of drag, like moving through air or through water or such type of fluid.
In the past, 2007, Igor says he has tried to use your lab for signal processing like FFT with scopes, etc., but found he wasn't able to get it working. But that was before he was. It looks like a much more mature company now. So hopefully,
I hope so.
I know I've actually emailed you some questions in the past, and I thought you did a real good job following up and getting answers for me. So I think you do a good job of that. So hopefully,
thank you.
I'll give you another chance today. Yeah, I was trying to do some. I don't know what I was doing. I was doing some weird audio stuff at one point. Some cool stuff here. So the OpenWire was the free one, and what was the other one you had that was free? Was the
OpenWire and iGDI Plus are both free open source products. And Me2 Runtime is a commercial library, but it will be free without source code, and we'll have some small price. We haven't decided the exact price yet on the source code version.
GDI Plus, excellent. Wire. Cool. All right. Well, thank you so much, Boyan. Pleasure as usual.
You're very welcome. It's my pleasure too. There are no more questions?
It doesn't look like there's any more questions. Oh, is OpenWire in FireMonkey?
That is correct. Yes, OpenWire supports both VCL and FireMonkey. It is a system-level type of library, so it can be used in non-visual components, visual VCL components, as well as FireMonkey components.
Otherwise, I think that's it. Yeah, great demo. Thank you. Lots of good feedback here. So thank you very much, Boyan.
Thank you. Thank you for the fantastic code rich.
I found one more question. There's no iOS support? Is that right?
Currently, there is no iOS support, not for other reason, but I simply don't have any iOS device, funny enough. But I'm a big Android fan. Nonetheless, we are looking to add iOS support in about a month or something. The code is compatible with iOS. If you get it with source code, you can probably extremely easily recompile it for iOS. But I simply don't have an iOS device to test with.
Okay, so it's not that you're necessarily doing anything that shouldn't work on iOS, just don't have a device to test it on to verify that it works.
I'm absolutely sure it's going to work on iOS because there is nothing specific in the library that's going to prevent it. Simply, I cannot claim it's going to work with something I haven't tested with.
Sure, that makes sense. All right, well, great. Thanks, Boyan.
Thank you.